Okay, so you know that gold ring you're wearing, maybe your wedding band. It's a simple circle, right? Symbol of love, commitment. But have you ever really thought about where that tiny bit of gold actually came from? Like the journey it took to get on your finger, the kind of impact, the environmental impact especially, that's hidden behind that simple little ring.
Yeah, it's so easy to forget that these really personal, symbolic things we have in our life are connected to this much bigger, almost invisible system, right? This resource extraction system that's literally the basis for everything in our modern world.
Totally. And that's exactly what we're going to be exploring today. So, like, we're going to trace the journeys of all these different raw materials, the unsung heroes, I guess you could call them, that really make our civilization run. We'll be looking at gold, of course, but also things like sand and salt that we just kind of take for granted, industrial powerhouses like iron and copper, oil, that global force, and then lithium, the new kid on the block in terms of energy. Oh, and we'll also touch on the world of recycled materials that's getting more and more important.
And looking at all the research we've got here, it's crazy how much effort, human effort, goes into just getting these materials. We totally take them for granted. But when you start digging a little deeper, pun intended, the consequences, the environmental impact, and all the historical and geopolitical forces involved, it's pretty mind-blowing.
Yeah, for this deep dive, we've gone through a ton of different sources. We've got journalistic investigations of gold mines like the Barrick Gold Cortez mine in Nevada. We'll be heading over to a really specialized sand mine, Lochaline in Scotland, figuring out what's so special about this particular sand. We'll dig into salt's historical significance with the Winsford mine in England and those archaeological finds at Bulby Cliff. Oh, and then we're off to the huge iron ore mines in Australia, the Hamersley Range, and the enormous copper extraction at Chuquicamata in Chile. We can't skip oil. Of course, it's geopolitical weight, especially with Saudi Arabia's Ras Tanura facility. Then there's the massive demand for lithium, especially in places like the Atacama Salt Flat. And finally, we'll wrap it up with material recycling, taking a look at Umicore and what they're doing.
And what we hope you get out of this, the listener, is a new perspective on the stuff we have all around us. We want to uncover these surprising facts and connections that'll deepen your understanding of the world without overwhelming you with too much technical mumbo-jumbo. Think of this as your fast track to being remarkably well informed about the stuff we rely on every day.
Awesome. Okay, so let's get started with gold, that shiny stuff that everyone loves. Our research actually takes us on a pretty crazy trip just to reach the Barrick Gold Cortez mine in Nevada. It's not exactly, a quick drive down the road.
Oh, no, not at all. It was multiple flights and a 4-hour drive across the Utah Salt Flats. Pretty desolate, let me tell you. And then another 2 hours driving with the mine staff. You're talking about seriously middle of nowhere stuff here.
Wow. Talk about remote. It really makes you think about the lengths we go to for this element. And our sources point out it's not just any location. The mine's actually on Mount Tenebo, which is like a sacred site for the Western Shoshone tribe. So right off the bat, you've got these questions about land rights, the cultural impact of all this resource extraction.
Yeah, absolutely. It's a really complex issue.
And then the mining process itself. On a basic level, it's pretty straightforward. You blast the rock, crush it, grind it into this super fine powder, and then you use cyanide to get the gold out. But the scale of it is just like mind-boggling.
What's fascinating is that the actual chemical process is relatively simple. You basically use a cyanide solution to pull the gold particles out of the crushed ore. But the industrial power, the machinery needed to do that on such a massive scale, that's the crazy part. And of course, you can't ignore the environmental risks that come with using cyanide to mercury, even with all the regulations in place. I mean, the EPA fined Barrick and another operator nearby for not reporting releases of toxic chemicals, so that really highlights the potential dangers.
Yeah, the sheer size of everything really hits you when you hear about it. The mining trucks are bigger than a 3-story building, and the tires, forget about it. They make a double-decker bus look tiny. They move a ridiculous amount of earth every day, like the equivalent weight of the Empire State Building. And get this, it takes around 5,000 tons of earth to make just one standard gold bar. That's like 10 of those fully loaded Airbus A380s, those super jumbo jets. It's incredible.
Right. It really puts things into perspective, doesn't it? It's so far removed from that image of panning for gold nuggets, like in a stream or something. Today, our sources say gold is rarely found in those rich veins anymore. It's all about these huge chemical reactions, basically destroying mountains to get at it.
So that gold jewelry we wear, it's not so simple anymore. Our research says that for a typical wedding ring, the amount of ore needed has gone way up. It used to be about zero point 0.3 tons, but now it's more like 4 to 20 tons. That's a huge jump. It makes you think about all the hidden costs behind it.
Totally. And it ties into this bigger issue of how we even measure our impact on the planet. The material flow analyses. Our sources talk about they're trying to figure out our resource consumption, but they often miss the waste rock from mining. We're talking about entire mountains, like Mount Tenebo, being moved and basically thrown away.
So all that waste rock, that massive footprint, it's not even in our regular economic data. That's crazy. Our real impact is probably much bigger than we realize. And apparently gold mining is just the tip of the iceberg. Compared to iron and copper, it's pretty small. And then when you consider the amount of sand and stone we move, forget about it. It's almost too big to think about.
It really emphasizes how much we take from the earth, how it shaped history and continues to shape it, often happening far away from us, out of sight, out of mind.
Okay, so from gold, this super shiny, precious thing, let's move to something that seems totally ordinary: sand. We see it everywhere, right? Beaches, deserts. But it turns out it's much more important than we realize.
Oh yeah, for sure. Historically, certain types of sand were absolutely crucial for specific crafts. Like, take the Cogoli sand from the River Ticino in Italy. This sand was super rich in silica, almost 98% silicon, which made it perfect for Venetian glassmaking. So it makes you wonder, where do we even find that kind of super pure sand today?
And that question takes us to, well, a pretty unexpected place, the Lochaline mine in Scotland. Just getting there sounds like an adventure. You drive north from Glasgow, take a ferry, then drive for miles on these single-track roads through this gorgeous but seriously remote countryside. You wouldn't go through all that unless you were after something pretty special.
Right. And to understand why that sand is so special, you got to look at the area's geological history. The Great Glen Fault, it's this huge crack that basically split Scotland in 2 millions of years ago because of these massive tectonic shifts. That played a key role in creating those unique sand deposits.
It's pretty wild to think about those forces working over millions of years, and it's because of those forces, like ancient sand dunes getting compressed into sandstone and then being ground down by glaciers, that the Lochaline sand is so special. It's got this incredible roundness and purity.
Exactly. Those perfectly rounded grains, they come from ancient beaches,
Ah.
and they're what makes it perfect for producing really clear glass. And unlike a typical sand quarry, the Lochaline sand is mined underground and isn't processed on site. Because it's so remote, it's shipped by water, hundreds of miles sometimes, to the factories that'll turn it into different products. That's pretty unusual for sand, and it shows you how valuable this particular type is.
Getting into the mine itself sounds pretty cool. There's a tunnel entrance right by the lock that leads into this underground network. They make you go through all these safety procedures. You have to wear a respirator, and then they show you these maps. There's this old hand-drawn map from the 1940s next to a modern one showing this huge network of tunnels. It's like a giant honeycomb under the ground. It's like stepping back in time, but also seeing this cutting-edge extraction operation.
And this high-quality glass, it's not just for making nice windows or anything. It's crucial for all sorts of technologies. Our sources even mention this crazy example. During World War I, Germany was supplying optical instruments, like binoculars and rifle sights, to Britain in exchange for rubber. Imagine that.
It's wild, right? The British were relying on their enemy for this crucial military equipment. It shows how important even seemingly basic materials can become, especially during a war. Our sources also talk about those weird glass taxes in Britain, like the window tax, and how they actually slowed down innovation and even led to those blind windows you still see in some old buildings. It's crazy how these policies, even if they weren't intended to do that, can have such a big impact on technology.
For sure.
Yeah.
And then when you think about how pure glass revolutionized fiber optics, it's mind-blowing. Calhoun's work was totally groundbreaking, building on the research into ultra-pure fused silica glass that happened at Corning back in the 1930s.
Yeah, fiber optics, which are made from this special sand, are basically the backbone of the internet, streaming, all that stuff. Without it, our digital world wouldn't exist the way it does. It's kind of amazing to think that something as essential as the internet relies on this specific type of sand from this relatively small mine in Scotland.
It really is, and it doesn't stop there. Sand isn't just for glass and fancy technology. It's a crucial part of these huge land reclamation projects, like the Palm Jumeirah in Dubai. They're constantly fighting erosion there. And then there's that massive Great Wall of Sand that China's building in the South China Sea. These projects show just how important even something as basic as sand can be in shaping, well, geopolitics, global politics.
So sand is not just beach stuff, it's in our most advanced technology and is shaping international relations. Okay, let's move on to another unsung hero, concrete. And guess what? Sand's a key ingredient there too, along with gravel, crushed stone, water, and of course, cement.
You got it. And the invention of Portland cement back in 1824 by Joseph Aspdin, that was a huge moment. Then the Germans came along and really refined the production process using a really scientific approach to get the recipes and the manufacturing just right. That really cemented its place, pun intended, as a foundational material for modern construction.
Our sources mention this funny story about Thomas Edison experimenting with concrete, not just for houses, but for furniture and even a phonograph. Sounds a little crazy, but it shows how much potential he saw in this material.
He was onto something. Today, concrete production is absolutely enormous. It's the most widely used material after water, with billions of tons being produced each year. It's literally the foundation of so much of our infrastructure.
But all that concrete comes at a cost, right? Environmentally speaking, making concrete is a big contributor to CO2 emissions, something like 8%, because of all the energy needed to heat limestone and make cement. Plus, it takes a ton of water, which is a big problem in areas that are already struggling with water shortages.
Exactly. Those environmental challenges are pushing people to come up with new solutions. We're seeing more sustainable alternatives popping up, like hemp concrete, something called concreting, even self-healing concrete using enzymes, and self-cleaning concrete too. And get this, they're developing concretes that are actually carbon negative. Pretty amazing.
So even for something as established as concrete, there's still room for improvement. Okay, let's move from the world of sand and concrete to another seemingly simple substance, salt. It turns out salt has a really long and interesting history, as we discovered at Bolby Cliff in North Yorkshire. Archaeologist Steve Sherlock made some pretty incredible finds there.
Oh yeah, his digs uncovered evidence of salt production from the Neolithic period, even before the Romans came to Britain. What's amazing is how much work it must have been back then. They were evaporating seawater in pots over fires. That shows how essential salt has been throughout human history.
Imagine the effort. It also supports the idea that a lot of early civilizations were near coastlines because salt was easier to get there. Steve's finds at Bolby Cliff are some of the earliest proof of that. And of course, salt has always been associated with value. We have sayings like earning their salt, and Roman soldiers were actually paid in salt.
And it was a vital food preservative for centuries, which made it super important during wars. Countries would stockpile salt and even try to destroy their enemies' salt supplies. It was literally a matter of survival.
Our sources also talk about how salt was used as a way to control people and collect taxes. China's a great example. They had a state monopoly on salt production and distribution that lasted for centuries, going back to the 7th century BC. And then there's the French gabelle tax on salt, which was so hated that it helped spark the French Revolution. It's wild how something we need to live could be used to control and exploit people like that.
It is. Interestingly, in China today, the government's role in salt is completely different. They focus on public health, adding iodine to salt to prevent iodine deficiency. So the same basic substance can have totally different uses over time.
Now, our research takes us to the Winsford rock salt mine in Cheshire. It's this massive underground cavern, almost like a cathedral, created with this room and pillar mining method, similar to the Lockeline mine, but way bigger. They describe these huge tunnels, the air thick with diesel fumes and salt dust, old mining equipment left behind. It's a whole different world down there.
And those hexagonal salt veins running through the rock salt at Winsford, they're a reminder of how salt forms. You see the same hexagonal patterns in the salt crystals that form in evaporation ponds in places like the Balearic Islands. It's the same process, just happening in different ways.
And guess what? Those salt caverns have some pretty important uses today, beyond just table salt and de-icing roads. They're being used to store hazardous waste as emergency natural gas reserves in Europe, especially after what happened with Russia and Ukraine, and even as part of the U.S. strategic oil reserves. Looking ahead, they could be really important for storing captured CO2 and green fuels like hydrogen. So we're finding all sorts of new uses for these ancient salt deposits.
Right. And we can't forget about the deep Bolby mine, which goes down almost 1.5 kilometers. It's a whole different beast compared to the Cheshire mine. Super deep, super hot, and the salt deposit is different too. It really shows how diverse these underground salt formations can be.
So from the depths of the earth to the heart of industry, let's talk about iron and its transformation into steel. One of our sources makes this really striking statement. Steel has no nation.
Yeah, it's a powerful idea highlighting how global and interconnected this material truly is. Throughout history, iron and steel have been drivers of huge societal changes. Just think about Andrew Carnegie and his massive steel mills in the early 1900s, like the Edgar Thomson Works. He basically dominated the industry.
And then there were those technological leaps in steel production, the Bessemer process, the open hearth furnace. These totally changed the game, allowing for huge increases in production and a massive drop in prices. It's amazing how those innovations shaped the world we live in today.
Totally. And specific alloys, like chrome vanadium steel, were key for certain industries. That particular steel, strong but lightweight, was essential for Henry Ford's Model T. Without those advancements in materials, mass-producing affordable cars might have been a whole different story.
And speaking of scale, the modern extraction of iron ore is just colossal. The Hammersley Range in Western Australia, discovered by Lang Hancock, it's basically a mountain range made of iron ore. That's how much of it there is. It can literally supply the entire world.
It's mind-boggling. And comparing these modern mines with their explosives and massive earth-moving equipment to the older, more manual methods is pretty striking. This shift in scale really started with the Mesabi Range in Minnesota, which supplied the steel for America's car industry in those early skyscrapers. These open-pit mines are like scars on the landscape, showing how much we're willing to reshape the earth for these resources.
And of course, that kind of extraction comes with serious environmental consequences, leaving behind those giant pits. Our sources also talk about the Azovstal steelworks in Mariupol, Ukraine, which was under siege during the Russian invasion. It was a key strategic target, but it also became a symbol of resistance. Even in the 21st century, steel is still a vital and fiercely contested resource in global conflicts.
And we can't forget about the close connection between coal and iron during the Industrial Revolution. Coal was the fuel, and iron was what the machines were made of. Like Watt's steam engine wouldn't have worked without Wilkinson's iron castings. That combination of energy and materials defined that era.
It was a major shift, for sure. Britain's move from using wood and charcoal to coal as fuel was a huge factor in their economic rise. They were no longer limited by how much land and forests they had.
Absolutely. And that brings us to copper, often called the second greatest thing after iron. It's absolutely crucial for electricity, which powers, well, everything.
Michael Faraday's discovery of electromagnetic induction really changed everything. The idea that a moving magnet near a wire creates electricity that's the basis for generators, and those rely on copper windings to turn mechanical energy into electrical energy.
It's the foundation of our electrical world. From power plants that run on fossil fuels to renewable energy sources like wind, geothermal, and hydro, they all need copper. And of course, pretty much every electrical device we use has copper in it. While aluminum is used for those long-distance power lines because it's lighter, copper's still the king of conductivity. It just performs better.
The scale of copper mining is pretty wild, too. The Chuquicamata mine in Chile, the largest open-pit copper mine in the world, it actually dwarfs even those massive gold mines in Nevada, both in terms of what it produces every year and how much it's produced overall. The numbers are just hard to wrap your head around.
And there's this sad story about the town of Chuquicamata, which basically became a ghost town as the mine grew bigger and bigger. It's a really stark example of how resource extraction can impact communities. The encroaching mine, the dust, the fumes, it all led to the town being abandoned.
It shows the difficult choices that have to be made. You have this huge operation, these deep pits, massive explosions, gigantic trucks working 24/7 to get this copper we need, but it comes at a human and environmental cost. Our sources describe this water-intensive process called heap leaching that's used at Chuquicamata. They extract copper from the crushed ore using water, which seems kind of crazy given that it's in the Atacama Desert, one of the driest places on Earth.
It's a paradox, for sure. And the history of Chuquicamata is a long one. It started with guys like Daniel Jackling and the Guggenheim family extracting lower-grade ore with steam shovels. Then it was sold to Anaconda Copper, who were even more aggressive in their mining. It shows how the pursuit of resources can really escalate over time.
What's really interesting is that the grade of copper ore has actually gone down over the 20th century. That means there's less copper in the rock, so you need way more energy and water to get the same amount of copper. And yet the price of copper hasn't really changed much after you adjust for inflation. It's like we're working harder and harder for the same result.
That's the thing, the mining industry is constantly innovating, coming up with new technologies to keep extracting copper efficiently, even as it gets harder to find. Like they use this block mining technique in the deeper parts of Chuquicamata. Our research also mentions the potential of deep-sea mining for copper in those black smoker vents on the ocean floor. They've got high-grade copper ore, but we're not sure how much there actually is compared to what we find on land.
All right, let's dive into the world of oil, that black gold that's had such a huge impact on the world. Our sources talk about how people were skeptical about finding oil in Saudi Arabia until that game-changing discovery at the Dammam number 7 well back in 1938.
Yeah, that discovery changed everything, literally rewriting the global energy map. It's also interesting that geologists had figured out this connection between salt domes and oil and gas deposits. The Chinese actually knew about this centuries ago. That knowledge was key to finding those massive oil reserves under the Persian Gulf.
And then the discoveries in Iran, Iraq, Kuwait, Bahrain, it all led to this huge influx of American and British oil companies. And that set the stage for oil's massive geopolitical power, which continues to this day. Our research also highlights how crucial oil was during World War II for both sides. Germany, worried about running out of oil, actually started making synthetic fuels from coal using the Burgess process.
It shows how vital it was to have reliable energy, especially during a war. And the Allies knew that, which is why they bombed those German synthetic fuel plants at Leuna and Bühlen. It really crippled the Luftwaffe.
On a darker note, our sources discuss the really harmful effects of leaded gasoline, which Thomas Midgley Jr. basically discovered. People knew it was toxic early on, but they kept using it anyway. It's a classic example of how greed and short-sightedness can lead to huge environmental and health problems. It took decades to finally ban leaded gas worldwide.
It's a cautionary tale for sure. But the story of the Wesseling plant in Germany is interesting. It used to make synthetic fuels during the war, but now it's a high-tech oil refinery. And get this, they're planning to use more sustainable stuff, like plant oils and waste products, to make fuel. That gives me some hope for the future of the energy industry.
It's easy to forget how much modern agriculture relies on fossil fuels, too. I mean, there's natural gas for fertilizers, pesticides that come from oil, and the whole transportation system to get food around the world. Our sources talk about this new trend of environmentally controlled agriculture with greenhouses and vertical farms. They're trying to produce more food with less land and water, but they still need a lot of energy, most of which comes from fossil fuels right now.
Right. And then there's the whole world of plastics, which are made from oil. It's amazing how the accidental discovery of polyethylene at that ICI lab in Northwich changed the world. It revolutionized packaging and so many other things. But our sources point out how hard it is to recycle plastic. There are all these different types. And new plastic is so cheap to make that recycling just isn't as appealing. We've created a real mess with plastic waste.
Polyethylene is everywhere, and the amount we produce is mind-boggling. But those massive oil export facilities at Ras Tanura in Saudi Arabia, they really show our global dependence on oil. It's a constant stream of those huge, very large crude carriers, those VLCCs, keeping the global economy going. And even though we need to move away from fossil fuels, the reality is that we still rely on oil and gas for a big chunk of our energy. The energy crisis after Russia invaded Ukraine really showed that.
It definitely highlighted how important oil and gas still are and how challenging it's going to be to switch to cleaner energy. But our research also suggests that this transition could lead to a new era of mining, where materials like lithium become the new hot commodity, the new white gold, so to speak.
Which brings us to lithium, the key ingredient for electric vehicle batteries and those big energy storage systems. Our sources take us to the Atacama Salt Flat in South America, where they get lithium from this brine that they pump up and put into these giant evaporation ponds.
It's an interesting industry in Chile. SQM, the main company there, they were focused on potash at first, with lithium just being a side thing. It wasn't until electric vehicles and renewable energy really took off that lithium became super valuable.
It's funny to think about how lithium used to be used for things like treating bipolar disorder and strengthening glass, making alloys, and even as a lubricant. But the big game changer was Stan Whittingham's work on batteries. He figured out how to make lithium ions move back and forth in a battery without damaging it, which made rechargeable batteries possible. Our sources use this analogy of lithium atoms moving between apartments and offices in the battery, which is pretty helpful.
That back and forth movement is how lithium-ion batteries work. But extracting lithium in the Atacama Desert, well, it's controversial. There are concerns about the impact on water resources, both the brine they use for lithium and the fresh water that local communities rely on.
Yeah, people are worried about the fragile desert ecosystem there, the Andean flamingos, and the indigenous communities who consider the salt flats sacred and the brine part of their water resources. It's a complex situation with lots of different viewpoints.
And the mining companies argue that they don't use that much water compared to other industries and that there's enough fresh water around. But as our research points out, the question is, what even counts as water in this case? Is that brine, which is used for lithium extraction and is part of the ecosystem, something that needs to be protected?
It's a tough question. We need lithium for a greener future, but we have to consider the impact on the environment and the people who live there. It's a balancing act.
Definitely. And that leads us to recycling, what our sources call the urban mines of tomorrow.
They talk about this Umicore plant in Belgium as an example. They're getting valuable metals, lithium hydroxide, gold, silver, nickel, cobalt, copper from old electronics, batteries, all sorts of things. It's a great way to reuse resources and hopefully lessen the impact of traditional mining.
Absolutely. While recycling rates vary for different metals, steel and aluminum are pretty high, but lithium's is under 1% right now. The potential for recycling is huge.
Yeah.
If we can get better at it, we can move towards a circular economy where we're not just taking new resources all the time.
It's ironic, isn't it? The oil industry, which is known for being super efficient, is also the one that gave us the plastic industry, where everything's so cheap and disposable that recycling just hasn't caught on.
It is a bit of a paradox, but things are changing. There's a lot of investment in lithium-ion battery recycling now, with companies like Redwood Materials, Li-Cycle, GEM, and Brump leading the way. Umicore's plant shows just how complex battery recycling is, from taking apart these sealed battery packs to using these huge furnaces to recover the metals. It's interesting that the lithium itself releases a lot of energy during that process.
So we've covered a lot of ground here, from those remote gold mines to the salt flats, from the depths of those salt caverns to those sprawling oil refineries. It's been quite a journey, and it really highlights how connected these raw materials are and how they shape our lives and drive all this technological advancement.
And when you think about how fast technology is advancing, especially with things like Wright's Law, and how the energy density of fuels has been increasing, along with their overall energy consumption, it's clear that we're putting more and more pressure on these finite resources.
That brings us to a really important point. The way we're consuming resources right now, it's just not sustainable. Our sources mention some pretty serious risks to the global supply of raw materials, like we're not finding new deposits as quickly as we used to. It takes more energy to extract the materials because the ore grades are declining. There's always the risk of geopolitical instability. And there might even be a shortage of skilled people in the mining and materials science fields in the future. In fact, the Camborne School of Mines, a really prestigious institution, just closed their mineral engineering program, which is a pretty clear sign of the times.
Yeah, there are definitely challenges ahead. But our research gives me some hope, too. If we understand the complexity of the materials that make our lives possible, we can start to build a more sustainable and cleaner future. These 6 materials, sand, salt, iron, copper, oil, and lithium, they've been driving human progress for centuries. We just need to learn how to manage them responsibly.
So next time you look at your phone, your car, the buildings around you, think about where all those materials came from, the journeys they took, and think about our responsibility to use them wisely and make sure there are enough resources for the future. It's something we all need to think about.
For sure. This deep dive into materials is just the start. I encourage you to keep exploring these topics, to read more about it, to learn more. There's a whole world of information out there waiting to be discovered about the very stuff that makes our modern lives possible.